Hello everyone. We are going to see the total internal reflection, that is TIR, in Prism. So to see this topic, let us see first of all what is the prism. Prism, we know that it is a refracting medium. We know that light can pass through it, the prism, but we are going to show the phenomena of reflection, internal reflection through it. So see how it can be possible. We are knowing that prism is a refracting medium and it has 5 surfaces. In these 5 surfaces, 2 surfaces are triangular, 2 triangular surface, and other 3 rectangular surface. Triangular surface 2 and here rectangular surface 3. Now see, this prism is normally of 3 type. We are going to see type of prism. Here in this type of prism, see carefully. The one type of prism we are going to see, the symbol of a prism is, we show a triangular surface here on a plain paper. 2 triangular surface. The first type A is called right angled prism. The base of prism is a right angle. In this right angle, see, it is 90 degree and 45 each degree. So in that condition, these 2 sides are equal. Now we are going to see the second type, B. B is called the equilateral prism. This equilateral prism is, see, the base of the prism is here. All 3 sides are same. Here 60 degree, 60 degree, 60 degree. This is called equilateral prism. And now see the third type, C. Third one is, in this condition, C, it is also a right angled prism. See in it, 90 degree, right angle here, 30 degree and 60 degree. So third one is the different type, 90 degree, 30 degree, 60 degree. 3 type of prism is commonly available. The first one, right angled base prism, in which 45, 90, 45. Equilateral base prism, 60, 60 and 60 degree. And the third one is right angled, is also here, 90, 60 and 30 degree. So these type of prism, all type of prisms are mainly refracting, showing the phenomena of refraction, refracting medium. But In a circumstances, we can show the phenomena of TIR in only certain circumstances in which the all two conditions of critical angle fulfilled. The first one is a light must travel from denser medium to rare medium, whereas angle of incidence must be greater than critical angle. We know that for air and glass medium, when we see glass and air in that condition, critical angle IC is equal to 422 degree. If angle of incidence is greater than this, then phenomena of TIR, total internal reflection, takes place, and it can be represented by using total reflecting prism 4590-45. It has the following uses. So the first use of the total reflecting prism is to deviate the ray of light through 90 degree. See here in the diagram, suppose we take a ray of light. When it is fall here this 90 degree, we are knowing in the refraction it's penetrate without deviation. So here is the glass. This medium is a glass and it is air. G stand for glass and it is air. See, at the interface of denser to rare medium, draw a normal. Automatically, due to design of this, the angle of incidence become 45 degree, and which is more than critical angle for pair of the medium. Here see, light is traveling from glass to air, denser to rare medium, and angle of incidence is greater than critical angle. Under this circumstance, ray of light turns back in reflection phenomena takes place. Here 45 degree again. So in place of being refraction, the circumstances are maintained in such a way phenomena of TIR, total internal reflection, takes place. So this total reflecting prism used to deviate the ray of light through 90 degree. See the second use. The total reflecting prism is also used to turn the ray of light through 180 degree. So see how it is possible. To see it, see the total reflecting prism. If it is designed in this way, suppose it is 90 degree and both 45 each, right? Take an object P Q. We are knowing that any ray diagram we are making from the object, a ray of light, see by the green color, a ray of light falling normally without undeviated path. See here, inside it is glass, air. Make a normal. This is 45 degree from its design. Fooling both condition of TIR, angle of incidence is greater than critical angle. Here is a 45 and for given it is 42 degree only. So greater than that, TIR takes place. So this ray of light reflected in this direction. It is also 45 degree. Now see again at this position, make a normal. Again it's turning back in this direction. Suppose. Now see the second. This is the first ray, moves in such a way. This is also both 45 E. This is second ray. Comes here similarly in this way, moving down. P dash, Q dash. This image is formed. So ray of light, see very carefully, two time bending. This is first ray and it is second ray. This is the first ray. So moving in this direction, turning through 90 degree, again 90 degree, total makes 180 degree deviation from its path. There is one more application of the totally reflecting prism. It is used to make a erect image of inverted object without any deviation. So see how it is possible. To understand this diagram, let us see very carefully. It is 90 degree and this both 45 each. Let us consider an inverted object is here. See, let's see how its erect image is obtained by using this total reflecting prism here in this. So you keep the total reflection prism in this way. Take a ray of light from both end of the object. When it's come here, see the normal at both positions. It is kept in this way. So it is air, glass and air. Air to glass, no fulfilling the conditions. Normal refraction will take place here. Let it is the first ray. This is the second. So see here, normal refraction. This is the normal here. First ray, second ray. TIR will take place here. Because here angle of incidence is due to 45 of this, 45 more than the critical angle. So phenomena of TIR takes place. First ray, second ray, here is a second ray. Again here, normal refraction, glass to air. It is in this way that angle of incidence is less than critical angle. So this ray is here. So tip will go up. Erect image. This is the inverted object and it is erect image. Now we have seen the three use of the total reflecting prism. The first use is to deviate the ray of light through 90 degree. Here in the first application, we can take a number of ray of light. reflecting through 90 degrees. This total reflecting prism is used to make periscope, or wherever it is required to change the ray of light by 90 degree. Actually it is used as a mirror. In mirror there is one polished surface, but in prism there is no polish. But situations are maintained in such a way that it follow the condition of TIR and internal reflections takes place. So periscope is used, this total reflecting prism is used to make periscope. The second application here to convert this total reflecting prism through 180 degree, here in the diagram. Clear it is? This diagram is also used in some specific purpose. It is used to make prism binoculars. Used to see the object, here in case. And the third use, where we make erect image of inverted object. We are knowing the negatives of the film is inverted image there. And in slide projectors, it is required to see the erect image. So the total reflecting prism, if it is used in this way, it make a erect image of inverted object. So this prism is used in slide projector. TIR can also be seen through second type of prism, which is used for this purpose, is equilateral prism. So see here how this equilateral prism can be used as a TIR phenomena. Let us see in this diagram very carefully. Let us consider this equilateral prism in which all three sides are same and each of 60 degree. So this is the equilateral prism. Any doubt? No. Now take a ray of light, falls normally on equilateral prism, 90 degree here. In that condition, when this is called incident ray. See, this is incident ray, falls normally, passes the glass medium without undeviated and reach here on the surface. Glass, air, air is here. See, glass to air, draw normal. Due to its design, it is 60 degree, right? So angle of incidence is greater than critical angle. Due to this design, internal reflections takes place. In reflection, we know both angles are same. So it's turned back, again it's fall normally and move in this directions. So this is called emergent ray. Emergent ray emits from this, not this side. If it is prism is not available it, then this ray of incident ray must move in this direction. But due to this equilateral prism, its return reflected by this face. So total reflection phenomena can also be seen through equilateral prism. TIR, that is total internal reflection, can also be seen through prism 30 degree, 60 degree, 90 degree. Let it is 90 degree, 60 degree and 30 degree. Prism A, B and C. Let a ray of light is here like this. Here 90 degree falls normally on base, passes without undeviated according to the law of refraction. See, this surface is glass, air, air. At this point of interface, it is required to draw normal. Right? Due to the design of this, the angle of incidence becomes 60 degree, and which is more than critical angle for pair of media, because we know that 42 degrees critical angle for this is. So in that circumstances, this incident ray reflected like this. In that circumstances, this angle becomes 60 degree. Again, draw normal. Due to its design, at this side, the angle of incidence angle becomes automatically 30 degree if it is 60 degree here in this case. Now, so here angle of incidence is less than critical angle, because critical angle is a 42 degree and this angle of incidence is 30 degree. So no TIR will take place. Light is passes from glass to air, denser to rare medium, but not, this is the first criteria in which light must travel from denser to rare. But for TIR, the second condition may also fulfill, that is, angle of incidence must be greater than critical angle, but it is not following. So no TIR will take place. Here normal refraction, glass to air, bending away from the normal. Bending away from the normal means ray of light will move away from it. So in that condition, angle of emergence will be greater than the angle of incidence here in this case. So this TIR through 30, 60, 90 degree, here TIR is taking place at this position, can be obtained by it. See once more the whole lecture here. We have taken here total reflecting prism of 3 types, which is used as a TIR: right angled base prism, equilateral base prism, and a right angled base prism of 90, 30, 60, and it is 90, 45, 45. All 3 are used here in this case to show the phenomena of TIR. For the reflection phenomena, we can use mirror also. Mirror is also, see very carefully, is used to show the phenomena of reflection of light. And prism is used for the phenomena of refraction, but these 3 type of prism is used for TIR, total internal reflection of this configuration. See, why we are using mirror, why are you using prism over mirror to show the phenomena of reflection? So one thing is very common, I have told to you, it is used to make periscope, it is used to make prism binoculars, it is used to make slide projectors are used. So when we use for this purpose, aforesaid purpose, If in TIR there is 100% of light turns back. So very clear cut image is obtained as the intensity of the object. But when we use a mirror, the mirror shows reflection, partial reflection, and it shows TIR 100% reflection. That is why for making periscope or binoculars or slide projectors, or we have used to some different types of the prism here to show the TIR pattern. So this is for the topic. Thank you and have a nice day to all.